Hey folks, welcome back. Today we're going to look at a little bit of a review. So let's look at our question of the day first. What does this graph tell us? This graph is a solubility curve. Remember, the bottom is temperature in degrees Celsius. In this case, we're going from 0 to 100 because this is when water is in the liquid phase. On the y-axis, we have grams of solute. How much stuff dissolves, how much solute can dissolve in the solvent. So each curve represents a specific material. Most of these are compounds, some of them are elements, and what we want you to do is to figure out how much material dissolves. As you can see, the majority of these curves are increasing as you increase temperature, but sometimes the amount of solute goes down. You can actually read from the graph at a given temperature how much material will dissolve in grams. Don't forget, guys, Survivor Project, if not already turned in, we've got our test coming up. That's why we're reviewing. So let's review a little bit some of the materials. All right, so I've provided a review packet in addition to the one in your notes packet. This is more of an updated one, so if you haven't seen this, please go ahead to Schoology and check out the review packet. You can download, type on it, do all sorts of things. You don't have to turn it in or anything, but please make sure you do it as we go over the answers today for our review packet. All pure elements are listed on this chart. This chart is called the periodic table of the elements. All matter is made of these tiny particles called atoms. An impure mixture that has different properties throughout. Different properties meaning that you can see them is heterogeneous mixture. The process used to separate water from salt is distillation. The process used to separate sand from salt is filtration. The universal solvent is water, and since you can't see the ingredients in the air, it's homogeneous. A mixture that is so evenly mixed. Take a minute and make sure you have all the right answers and you understand these definitions. Okay, the maximum amount of solute at a given temperature is the dissolubility rate or solubility of that material. In solutions, the substances that are being dissolved are solutes. There you go. Always the title of the x-axis. X-axis is at the bottom, which is temperature. For our dependent variable, we always put our dependent variable on the the y-axis, which is the up and down axis. This represents the change that you'd expect to see depending on, in this case, temperature. The two materials that are chemically combined make a compound. And a physical combination of two materials that don't chemically combine, that are impure, are mixtures. Okay, so now hopefully you've got enough information to complete the code, crack the code. Determine how to crack that just by filling in the letter that's associated with the numbers above. All right, good luck figuring that out. And let's go on to our next couple questions. Use the graph to answer the following questions. Remember your units. Looking at this graph here, what's the mass of solute dissolving in 100 milliliters of water at a certain temperature? So I need to find KNO3 at 70 degrees. All right, let's highlight KNO3. KNO3 is that line. And let's find 100 degrees. This will be the boiling point. Oh, sorry, 70 degrees for this question. So at 70 degrees, KNO3 intersects at this point. So we'll simply read across to find the grams, which is 130 grams. Units are G. Sodium chloride, which is salt at the boiling temperature of water. So my sodium chloride is this line here. At 100 degrees, we're at about 40 grams of salt. So that's much less than our KNO3. This material at 90 degrees, NH4Cl, that looks like a compound can be found right here. So finding it first is probably the most important part. Then you can plot out where it is. 90 degrees is here. And it looks like we're at 70 grams of material being able to dissolve at that temperature. Which material becomes less soluble? To find that, we're going to look for any material that decreases. In other words, the curve goes down. I see a couple of answers. NH3, Ce2, SO4, 3. So those two are great answers. What's an appropriate title for this graph? This is a solubility graph. It tells you how much material will dissolve at given temperatures. Let's do the matching. Okay, we've got mixture, solution, solvent, solute, element, and compound. When I like to match, I like to look at the definitions first and then match with the word. It's a little easier to think it through that way. Salt will dissolve in water. Salt is the solute. Water will dissolve salt. Water is the solvent, the universal solvent. A physical combination of two or more materials is a mixture because it's physical. Two or more elements that are chemically combined is a compound. A pure substance made of one type of atom is an element. Remember how we sorted in the beginning when we classified things? Element, mixture, compound. All matter can be classified. Oh, that might have cracked the code for you there. All matter can be classified as either element, mixture, or compound. What's left? Homogeneous mixtures where all materials are evenly spread out. That's a solution. So it's impure, homogeneous mixture. Materials can settle out like sand in water. That's a suspension. Milk or blood are great examples of colloids. Materials somewhere in between a suspension and a solution. You can't necessarily see them, but they do scatter light, so they're going to block light. Evenly mixed solutions are homogeneous, and mixtures with uneven blending are heterogeneous. Which material is soluble? Okay, so let's take a look. We have salt and sand and water. The soluble material is the salt. That means it can dissolve. Which is insoluble? The sand. You could mix it and make a suspension, but it will just settle out. What did they do next? They poured the sand and salt and water in through a filter. And what we get looks like this clear because the sand is caught. 15 days later, only salt remains. Well, the salt must have come through with the water, and then the water evaporated away, leaving just the salt. So they've separated the water, sand, and salt, but the water is now a gas in the air somewhere. All right, we've got our pictures here. Remember, the circles represent atoms. If they're touching, they're compounds. The element is the one that represents the single type of atom. A compound and element was not seen in any of these pictures. The 3-atom compound was choice 3. The physical separation method was choice 2. Which choice is a mixture of different compounds? It's choice 2. You can physically separate mixtures. You cannot physically take the atoms away from a compound. Okay, time for review. You can check Schoology for other review activities and other kind of Quizlets and things like that. Hey, good luck. Don't forget, this whole unit is really based on classification. Matter, things made of atoms, solid, liquids, or gases, either way, could be pure with consistent compositions at all times. Pure materials could be elements of one type of atom or compounds that are chemical combinations. They're pure because they're always the same everywhere. In compounds, you have formulas like H2O, CO2, It means they're always the same. That's why they're pure. Mixtures are things where we mix physically two materials. And sometimes the mixture can be heterogeneous, where we see the parts, and sometimes homogeneous, like salt and water, where we don't see the parts. We talked a lot about mixtures, and we talked about solutions and colloids, which are homogeneous, and suspensions, which are heterogeneous. So all of the words and all the things we did basically help you figure out how to classify materials into different categories. That's what this unit's all about. And hopefully you were able to follow that review, and hopefully you're going to do really good on this test. I'm sure you will. So thanks for tuning in and trying science. Good luck. We'll see you next time.